I'm finding stuff out that you want to know. Just ask me a question that I don't know. That's why Finding Stuff Out is the name of the show. So just give me a shout and we'll figure it out with the help of some friends, and the fun never ends on Finding Stuff Out, Finding Stuff Out, Finding Stuff Out. That's what it's all about. Yeah.
Hi, welcome to Finding Stuff Out. Today, I'm dressed up fancy because your questions have inspired me to have a big star on the show. The biggest, most famous star on Earth. Wait, did I say on Earth? I mean, the biggest star in our whole solar system. Put your hands together for the sun.
Yeah, the sun. I love the sun.
Yes, the sun truly is a star. But if it's so great, then how come, as Anastasia asks,
why can't everything be solar powered?
solar is another word for sun, as in energy from the sun.
The sun is very, very big compared to the planets in our solar system, including Earth, and it also has unimaginable amounts of energy.
So I wonder, maybe everything could be powered by the sun. Like this solar-powered baseball cap with a fan to keep me cool, or this solar-powered bobblehead.
And how about using the sun to cook food?
This is a solar cooker I made. It doesn't need any electricity or flames to cook things, just sunlight. Well, that's what they say. But is it really true? Let's check back at the end of the show to see what happens to this egg. Meanwhile, you sent me a lot of other questions about the sun that need to be answered, like this one from James.
What is the sun made of?
Well, James, I checked and found out that the sun is a giant ball of super hot gas, mostly hydrogen and helium. Some of it is like what's inside of this helium balloon. But what's happening to the gases inside of the sun is incredible. Here's why.
Gravity is a force that holds us onto the Earth and keeps us from being flung out into space as it spins. Without it, this would happen. The sun is huge compared to the Earth, so its gravity pulls on the Earth and all the other planets in our solar system, so they circle around the sun.
The sun's gravity is so powerful, it actually squashes the hydrogen in its core, which is this part deep inside it.
When that happens, it creates incredible amounts of energy as it turns the hydrogen into helium.
Okay, my balloon isn't really doing that. It's not big enough to have that kind of gravity, but if I squish it enough, maybe it'll create enough pressure to have my own mini sun and power something. I'm not giving up. I'm going to bring in an expert to help me do this. She discovers galaxies, so I bet she can help me. Please welcome my special guest, astrophysicist, Dr. Tracy Webb.
Hey, Harrison.
Hey.
I brought you a picture.
Whoa, is that anybody I know?
Well, it might look familiar. It's a galaxy, very much like our own Milky Way galaxy, the one that the sun lives in.
What is a galaxy?
Well, a galaxy is a collection of usually billions or even tens of billions of stars which are held together in space by their own mutual gravity. They're kind of like an island universe within the universe itself.
Wow, billions of stars. If Tracy knows that much about space, maybe she can help me make my own sun.
Okay, so I have this balloon filled with helium and a bit of hydrogen, just like the sun. Yes, I'm gonna compress you into a sun with this. Oh, it's almost there. It's getting warm. I can feel the heat building up. Oh, now I don't have Mr. Sun or Mr. Balloon. But at least I still have you, Tracy. What went wrong?
Well, the hydrogen and the helium in the balloon doesn't actually want to be squished together. So it fights back. That's what we call pressure. And you're just not strong enough to squish all of those atoms together. But I can show you what's happening in the center of the sun using this demonstration with Play-Doh.
Okay.
We're going to pretend that these 4 yellow Play-Doh balls are hydrogen atoms. And now we're going to put 100 million elephants on top of it.
I don't have 100 million elephants.
And that's going to create the pressure, like the pressure in the core of the sun, and it's going to squish these hydrogen atoms together to form helium. And when it does that, it releases energy.
Well, I don't know where I'm going to find 100 million elephants, but I do know where to find another question.
Why is the sun a star?
Yeah, why is the sun a star?
Well, the sun is a star like every other star that we see in the sky. It just looks different because it's so much closer to us. And for a long time, we did think that it was something different, but now we know that it's not. But it's still a really important star because it's the center of our own solar system, and it is the brightest thing in the sky.
That's right, Mr. Sun. You'll always be special to us. Even if out there you're just one of millions. I mean, billions. I mean, how many stars are there?
There's over 1 billion stars in our own galaxy, and there are billions and billions of galaxies in the universe.
So would it be like how many grains of sand are in this bucket?
Nope, there's more than that.
More than this? What about the grains of sand in this whole pool here?
No, you would have to take more grains of sand than are on all of the world's beaches, and you probably still wouldn't even have enough stars.
Yeah, my parents aren't gonna let me bring more sand in here. So let's bring back the sun for another question. That's bright.
Why, when you look at the sun, your eyes burn?
Yeah, why is that?
Well, unlike the stars, the sun is really close to us, so the light from the sun is still very energetic when it reaches the Earth. The stuff that damages your eyes is called ultraviolet light, and you can't see it, and you can't feel it actually burning your eyes.
So it's kind of like when I go to the beach, I put on sunscreen.
Yeah, it's the same stuff that gives you a sunburn, and you don't know that you're getting a sunburn until it's too late also.
What about during an eclipse?
During an eclipse is when the moon passes in front of the sun and blocks all the visible light, but it doesn't actually block the UV light. That can still come through to your eyes even though you can't feel it or see it.
So you should never look into the sun even during an eclipse?
Never.
Are all the sun's invisible rays dangerous?
No, not all of them. And in fact, some of the stuff that comes, some of the energy that comes from the sun can produce things that are very beautiful on Earth, like the northern lights.
Oh, I think I have some video of that. They're so beautiful. What makes them happen?
Well, you remember that I said the sun was a big ball of gas, and that gas was made up of particles of hydrogen and helium. And a lot of those particles are being blown off from the surface of the sun all the time, and we call this the solar wind. And that wind of particles goes through space and gets captured by the Earth in the North and the South Pole. And as those particles come down into our atmosphere, they collide with other particles, oxygen and nitrogen, and cause this explosion of light that we see.
The experiment.
For those of you who have never seen the Northern Lights, you can do a quick little experiment at home to see what they look like.
Awesome.
So get an adult to help you assemble all these different ingredients. You need some 2% or whole milk. You need some pretty food coloring colors.
Yeah.
And some regular dish soap.
Okay.
And what we're gonna do is we're going to pour the milk into this pie plate here.
Okay.
And then once it's settled down just a little bit, we're gonna put some green in and some red. We don't want them to mix yet, so I'm putting them separately.
Right.
And then
The
some
blue.
blue.
Whoa.
And then I'm gonna take the dish soap and just put a little bit right in the middle.
Whoa. Cool.
So you see how it makes swirls and curtains? That's exactly what the Northern Lights look like.
Cool. Thanks for helping us find stuff out. Now here's a question from James.
What would happen if someone walked on the sun?
The short answer is the worst sunburn you'll ever have in your life. And that would be a very short life if you tried to walk on the sun, because it's so hot. Yikes! My toesies! The sun is so hot, you wouldn't even be able to get close enough to walk on it. But if you could beam yourself up onto it, you'd be burned up in less than a second. And it's not solid anyway, so it'd be like trying to walk on a burning cloud. Scary. Which leads to a question from Kevin.
How hot is the sun?
How hot is it? Hot enough to give me a sunburn. Hot enough to melt crayons. The sun is hotter than all the candles. Hotter than an oven. Hotter than a furnace. Hotter than my head, which is getting really hot. 150 million kilometers times all those degrees. Solar meltdown, here I come. Ah!
You're gonna make my head explode.
I checked and found out that the hottest thing on Earth is the lava from a volcano.
It can be 1,300 degrees Celsius. That's 40 times hotter than a really hot summer day. But the surface of the sun is 6,000 degrees. That's more than 4 times hotter than a volcano. But the center of the sun is way hotter than that, 15 million degrees. That's more than 11,000 times hotter than a volcano.
Luckily for us, we're just the right distance away from the sun's heat. Scientists call it the Goldilocks effect. It's kind of like this.
If the Earth was further away from the sun than it is now, like where Mars is, the sun's heat wouldn't reach us and warm the Earth enough for life to exist. Aw, my porridge is too cold. In fact, everything is too cold. If the Earth was closer to the sun, like where Venus is, the sun's heat would be too strong. Huh? And now my porridge is on fire! Ah! Person, get me out of here! Ah, not too hot, not too cold. Everything is just right. Except someone ate all my porridge!
Excuse me.
Why does the sun have to come out in the day and not at night?
The Flat Earth Corner!
You want to know the answer? Well, you've come to the right place. I'm Homer, the famous Greek poet from the 9th century BC. So, why does the sun come up in the morning and go away at night? Well, as anybody in ancient Greece who's read my work knows, duh, it's because the sun god Helios rides his sun chariot across the sky every morning and disappears at night. Like this. Whoa. Whoa. Yeah! This is so much fun! I told you. Nowadays, we know that the sun is the center of our solar system, and the Earth circles around it, spinning. So unless you live in the North or South Pole, the sun comes up in the morning and goes away at night, like this.
The Earth. It spins around and around, so the sun comes up and the sun goes down. At night, we're turned away from the sun, but it's back again when the morning comes. At night, we're turned away from the sun, but it's back again when the morning comes.
We have morning and night because the Earth is always spinning. That gave the ancient people a solar-powered way to tell the time before clocks and watches were invented. It's called a sundial. Thousands of years ago, people used it to tell the time. It works by the sun casting a shadow on it. And that's today's
My Great Challenge!
Today, my great challengers are Amelia and Mateo.
The awesomest.
Okay, so you're gonna be Team Ra after the Egyptian sun god. Yeah. And you're gonna be Team Sana after the Viking sun goddess. So your challenge today is to find out the time using the sun. Well, actually it's a flashlight, but it will represent the sun.
I've made a giant sundial on the floor. The piece of a sundial that casts the shadow is called a gnomon.
Each one of you will try to find 2 different times of the day at different times of the year. The one to do it in the shortest time will be the winner. And remember, in the northern hemisphere, the sun lays low in the winter and it's high in the sky in the summer.
That's why there's 2 rows of numbers on my sundial. These are the summer times, and these are the winter times.
So Team Ra, you're gonna be first, and Team Sana, you can go downstairs so you can't cheat. Okay, here's your sun. Your first challenge is to find 9 a.m. in January. Go.
Mateo is moving the gnomon onto the square for January. Good move. He gets his shadow in the right direction, but here's the tricky part.
Yep, remember you have to have the point on the number.
Mateo needs to try and make his shadow shorter. He's raising his sun. Now lowering it.
And there you have it.
That's about how high in the sky the sun would be at 9 a.m. in January. Now let's see how Amelia does.
Are you ready for the first challenge?
Yeah.
Okay, 9 a.m. in January. Go.
Amelia quickly puts down her shadow caster. Now she's got to get the shadow to point to 9 a.m. Close, but that's 10 o'clock. She's moving the sun over, but it's got to be at the right height in the sky. She's raising it higher in the sky now, hitting 9 o'clock. But that would be where the sun hits in the summertime.
Remember, it's January.
Amelia is lowering the sun a bit.
There, she has it. Okay.
Amelia does it in 1 minute and 22 seconds.
Okay, are you ready for your second challenge?
Yes.
4 p.m. in July. Go!
The sun in the summer is higher in the sky. Let's see if the challengers figure it out. Mateo raises his sun. He's found the sun's position at 4 o'clock in the winter. But I asked for 4 o'clock in July.
On July.
And there you go, he's found it. Second challenge, go!
Amelia rushes to make up for lost time. Oh, it looks like she learned from last time.
Okay, you're getting really close. There, she has it.
And she did it! Now let's see who had the fastest combined times.
Okay, so Team Sana, you had a time of 1 minute and 44 seconds. Pretty good. And Team Ra, you had a time of 1 minute and 1 second. You're the winner! Woo, yeah. So, thank you for playing my great challenge. Now here's another sun question.
How do solar panels work?
Well, I know they take light and turn it into electricity, but I don't know how, so I went somewhere very cool to find out. This is Monty Gisborne, and he knows all about solar panels and how they work. And this is a solar-powered boat, and he's offered to take me on a ride. Thanks, Monty.
My pleasure, Harrison. Welcome aboard the Osprey, North America's largest solar-powered vessel.
Awesome.
Let's go.
This boat is much quieter than a gas-powered boat because its motors are electric and are powered by solar panels.
What we have here to show you is a solar panel, which is the primary source of energy that goes into this boat.
Right.
Basically, the rays from the sun strike upon the panel and excite the molecules of these crystals, which in turn creates electrons. Electrons is what electricity is made of.
Right.
The electrons start to flow through all of these cells individually.
Okay.
And that creates a circuit that flows through these wires, and then that energy is available for when our captain here needs to hit the throttle and make the boat go forward.
Okay.
I'm getting worried, though. We've traveled far, and it's getting kind of cloudy.
So if it got cloudy, like right now, would the boat just stop, or would it keep going, or how would that work?
Well, the truth is,
Uh-oh, I can feel bad news coming.
this battery pack is about 10 kilowatt hours.
Oh, good. That sounds like a lot.
That's about $1 worth of electricity,
We're doomed.
but that can run this boat for about 5 hours.
That's like a day's trip right there.
There it is.
Perfect.
We've got plenty of battery power left for me to drive us back. Good thing I have my boating license. And the best thing about this boat is it doesn't pollute. Solar power ahoy!
Well, this is great. If you could have anything that was solar powered, what would it be?
A car and a computer. A car.
A car, maybe like your toy car?
TV. Cars, because if you use fuel or gas, it will ruin the environment.
I would do different public buildings like hospitals or schools, because then anyone in the world could use them.
Nice. And what about you?
A blender and a bathtub, because I really like both of those things.
A blender and a bathtub. Those are two of my favorite things too, but don't combine them. That's a bad idea. And that brings me back to the question that started this solar quest.
Why can't everything be solar powered?
Well, Anastasia, the big answer is... almost everything does run on solar power, indirectly at least. Plants use the sun's energy to grow.
The wind that sailboats and wind generators use is made by the sun heating up the air. The rivers that run hydroelectric plants need the sun too. The sun evaporates the water, carrying it up to the sky where it cools, falls as rain or snow, then eventually flows down into the rivers again. Even the gasoline that we use to run our cars and the coal that we use to run some electrical generators were once, long ago, living plants that depended on the sun for energy.
But I think you mean, why can't we get all of our power from solar panels? Well, maybe one day we can.
Scientists are developing solar panels that can capture more and more of the sun's energy and convert it into electricity better than solar panels used today.
Hey, that reminds me. It's time to check on my egg. Oh, that's hot. I'll use this. Oh, it worked. That's excellent. So maybe by the time we're grown-ups, our cars, schools, businesses, and homes, and everything inside them will be solar-powered by the sun. But until then, I'm gonna wear this solar-powered hat to keep cool. Ah, that's better. See you next time for more Finding Stuff Out. Hey, this banana got its energy from the sun, and now I'm eating it. So I guess I'm solar-powered too. You want a bite? Well, I guess you'd rather have your solar power direct. Solar power.
You bet.
The Earth. It spins around and around, so the sun comes up and the sun goes down. At night, we're turned away from the sun, but it's back again when the morning comes. At night, we're turned away from the sun, but it's back again when the morning comes.